So next one is Weber image reject architecture. So we have seen that when you have mismatches, you will have serious issues in the Hartley architecture. So this image reject, Weber image reject architecture is going to have the same thing, but I'm going to use two mixers back to back. So you can see the diagram. You have RF input combination of two mixers. You have one in phase and quadrature phase. You are going to filter out the high frequency components. You are going to subject the same to another yellow at different frequency omega 2, which is also in phase and quadrature phase. You are going to filter out the high frequency terms. When you add, you are going to get the IF output. So this is the basic working of your Weaver architecture. So there we had only one 90-degree phase shifter block in Hartley architecture, but here we are going to have two separate down conversion and IF generation happening, and final IF is going to be the output which you're going to take from the image reject receiver. So it is derived from the Hartley architecture, and it is going to avoid all these issues of frequency mismatching. So it replaces, as I said, it replaces the 90-degree phase shift which we use in Hartley architecture with another set of mixer filtering operation. So that is the only change in the architecture perspective of Weaver image reject receiver. And same way you can supply the equations as we see. So A and B will be same because the architecture is same. And we C is going to be phase shifted version of A, and D is going to be phase shifted version of B. And you have four components because we are going to mix with one more frequency omega 2. So upon, and you can see here, I'm going to subtract XC from XF. So when you subtract XC and XF, you will see beautifully the signal is getting obtained here, whereas the image is going to be completely rejected. So this is going to be the RF frequency and this is going to be the IF frequency. So you can see when you subtract the two signals at the points E and F, you get back the signal and image is going to be completely eliminated from your circuit. So while employing two more mixers and one more LO than the Hartley oscillator, it avoids the uh, in Hartley architecture, we need to have these filters, low pass and high pass filters, right? But those are completely eliminated here, and I'm going to have two mixers and one LO additionally. So that is okay. If the system is going to do well, I'm not worried about having another set of mixer and LO. So that is not going to be an issue for me. And IRR is going to be limited by, and still, even though you introduce mixers and filters, all have to be perfectly working. So IRR is still limited by mismatches, typically falling below 40 dB. For image rejection ratios well above 40 dB, partly or architectures must incorporate calibration, a method of cancelling the mismatches. So 40 dB is considered to be a decent image rejection ratio. But if you want to improve your IRR to go beyond 40 dB, then you cannot use Hartley and Weaver architecture, and you have to incorporate methods where you can improve the performance of these two receivers. Otherwise, these two receivers will fail miserably at high frequencies.